Okay, good afternoon.
Hello.
Hello.
Afternoon, sir.
How are
Hello,
you?
afternoon, sir.
Good. How are you?
Fine, thanks. How are you? Fine, thanks. How are you?
No, I'm very good. Yeah. So
Oh, no, that's fine.
yeah.
Yeah.
Mm, yeah. So we'll continue. So this time around now,
Okay.
yes, we'll start with the actual measures that we can put in place to
Okay.
to counter soil erosion, soil compaction, or in short, soil degradation. So in short, we are
Okay.
going
We
to,
are recording.
yes. Is it showing? Yes, I think it's
Oh,
recording. Yes.
okay. Yes, I've seen it. I just wanted to check. Okay. Thank you.
Okay.
Yeah.
Okay. All right. Yeah. So we'll look at measures which are going to help us to ensure that our soil is conserved and it's able to perform its ecosystem functions. Um, okay. Yeah. So we'll to start with. Uh, we already defined what soil conservation is from the previous lectures. That basically it's just ensuring that the ecosystem functions of soil are able to carry on
Mhm.
in the soil. So in doing this, there are a lot of measures that we can put in place, but these measures can be categorized into different categories. So there will be what we call physical
Okay.
measures, agronomic measures,
Yes.
chemical measures, and biological
Yes.
measures. But all of them are ensuring that soil is not degraded, meaning that they are conserving
Yes.
the soil. So at the end of this
Okay.
chapter, you need to understand and be able to describe the different techniques that are used and the different categories, then the different techniques under each category, and as well just explain
Okay.
the mechanism with which this practice or this measure is able to conserve soils. So
Okay.
yes. So to start with, we can just go through the definition again. So since we are dealing with
Okay.
soil conservation, we need to understand what is soil conservation. So basically, it's just a
Yes.
combination of methods of soil management that safeguard the soil against physical, biological, and chemical degradation. So, but in this,
Yes.
yeah, in this context, we'll focus mainly on the physical degradation as we discussed previously. So these,
Yesterday.
yeah, so
Okay. Yes.
these conservation measures will ensure that your soil is not compacted and your soil is not eroded. So those two physical degradation processes are the ones that we want to safeguard against. So we know that
Okay.
usually land use uh, is one of the practices that will influence uh, soil erosion and soil compaction. And therefore, when we look at that
Mhm.
universal soil loss equation, we see that the C factor and the
Yes.
P factor are the ones that we can manipulate in order for us to reduce soil erosion. Or if we don't do them well, they
Okay.
will increase soil erosion. So as we go through each measure
Okay.
of these practices, you should be able to relate to the universal soil loss equation to say, okay, this practice, which factor does it influence? Does it influence
Yes.
the C factor?
Yes.
Does it influence the P factor? And how does it do that? Then we'll be able to now you'll be able to explain the consequence now of this management practice on soil erosion or on compaction.
Okay.
Yes. So as we said, soil conservation measures can be classified as physical, agronomic, chemical, and biological. So we'll go through them
Mm.
one by one.
Okay.
Yeah. So the first category we will look at is the physical measures. So
Mm.
these physical measures they involve building of structures or barriers or trenches, and mainly
Mm.
they reduce the velocity of water that is flowing on the surface.
Mm.
So
Okay.
yeah, so they can be achieved by constructing structures, for example, for example, trenches where water, instead of going down slope, you make a
Mm.
trench and the water goes in there and then it's moved away from the field, or you that water infiltrates
Yes.
into the soil and does not run off the field. But also you can just make
Okay.
barriers in the field to block water so that the speed is reduced. As you know, if the higher the speed of water, the more soil
Mm.
it will remove.
Yes.
Yeah. So mainly the principle here
Okay.
is
Okay.
the principle of reducing the velocity of water. So if you reduce the velocity of water, then the water will not have enough energy to erode,
Okay.
yeah, to erode the soils. So
Okay.
examples of these physical structures or physical measures, they are what we
Mm.
call cut-off drains. So basically, these
Mm.
ones are just trenches that are dug across the slope. So if the slope is going in one direction, you make
Okay.
a trench. So for example, in this,
Mm.
you see this picture here, B, you have a slope that is going in this direction.
Yes.
So what you do is that you dig a trench
Yes.
in this direction so that if water is coming this side, it is trapped in this trench, and now it cannot run off this side, meaning that you ensure that the place is not
Yeah.
eroded because the water is being trapped, and therefore the speed is
Mm.
reduced. So these are
Yes. Okay.
yeah, cut off drains.
Okay.
Yeah. So, but these ones again, you have to make sure that uh, 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 you have a slope maybe in this direction, so that as the water is coming, you're also
Mm.
removing it away from the field. So but the
Okay.
disadvantage again for this one is that it means that this space where you dig this trench, it means that you are removing it
Yeah.
out of production,
Mhm.
or it means that
Production. Yes.
yeah, it means that you can't use machinery as well across the the the,
Mm.
the trench. Yeah. So that's one. Those are the two disadvantages. Then something which is similar
Okay.
to cut off drains is retention ditches.
Yes.
Yeah. So these retention ditches, mainly
Okay.
they are there to retain water, but in doing
Okay.
that, they are also helping to reduce soil erosion. So the main purpose,
Okay.
is to collect water, but they also have
Mm,
an effect on reducing erosion. So the difference between the retention ditches and the cutoff drains is that in the retention ditches, you don't put a slope to carry away the water, but you leave it flat so that as the water is coming, it's settling in here, so that you have some water in these trenches, and now in these trenches you can also grow
okay.
crops.
Okay.
Yeah, so it saves two purposes. Unlike the cutoff drains, where
Okay.
it's just primarily for water to reduce the speed of the water.
Okay.
Yes. Then there are what we call water retaining pits.
Mr. Mitri, on the retention ditch,
Yes.
in terms of crops,
Mhm.
what type of crops can you grow in such ditches, trenches?
Yeah. So for example, you can grow bananas. You can grow mostly those crops which are like tree crops.
Tree crops, eh?
Yeah, yeah. Those which will not.
Okay, all right.
Yeah, because what will happen is that if you dig this trench, there will be some water which
Mm,
will be in here. So you have to make sure that the crop that you plant
mm,
is not very low. So the low crops,
Yes.
you plant them on top. Then here you
Yeah,
plant like tree crops.
tree crops.
Yeah,
Okay.
yeah.
Oh, so inangu pariji, inangu bufari.
Ridge then
Okay.
far more. Yeah, yeah.
Yeah.
Okay. Then we have water retaining pits. I'm sure you've seen this one where farmers just dig to my holes for to plant their
Uh,
crops. Mm. So this practice is
yes.
for conserving water, but because of this roughness
Yes.
that now you produce by digging the small pits, as the water is flowing on the surface,
Tunka kwati kumabari.
so it means that now
Yes.
speed will reduce and the erosion will
Okay.
also reduce. So these are
Okay.
yeah, these are common in my eastern province. They usually use these to my pits. They call it gampan.
Okay.
You just dig
Okay.
my pits here, but the actual purpose is for water retention. So you
Mm,
want water
okay.
to be storing in here, but because of the roughness that you have created, it also blocks water movement on the surface.
Mm,
Yeah. So that's the
mm,
water retaining pits. Then we have what we call check dams.
oh,
Yeah. So check dams usually
yes.
these ones are put in drainages or where there's a gully.
Mm,
So in drainages, for
yes.
example, if there's a lot of water that is passing through your drainage at a very fast speed, it will start eating up your drainage.
Mm,
So what they do is that they put
mm,
stones in the drainage. So if this is the
mm,
cross section of your drainage, you put stones here.
mm,
Again, you put stones here, such that
okay.
as this place is being
Mm,
eroded, it will become like a step. So you find that instead
okay.
of having a very steep slope, the slope will start to reduce, and
Yes.
the water is being blocked by these stones that you put. So if you get
Okay.
a cross section, you find that if your drainage is like this, then you block the water, like it's coming this direction to get blocked here. The speed reduces. As it moves from here to the next point, it will have a lower speed than it had previously. So these ones will protect the drainages as well as the gullies. So for example, like in Luswiti where we went, they use this practice as well, where they put stones
Yes.
in those gullies which the water makes. So they put stones so that they block
Okay.
the water movement. Then we have
Okay.
then we have bench terraces. So basically, these ones you want to reduce the slope, or you want
Okay.
to.
Just a comment on the check dams.
Okay.
Just a comment on the check dams.
Mm-hmm.
We also like we've got some fields that are under flood irrigation
Okay.
here. So
Okay.
sometimes you find we call them irrigators. These guys that irrigate our cane.
Okay.
So when they see that the slope is too much, sometimes they normally block the water. They
Mm-hmm.
put some soil.
Okay.
Then when the water reaches that point, in order for them, if water is too fast, you don't get that infiltration.
Yeah.
The water will just run quickly. So you find sometimes they block the furrow.
Mm-hmm.
Then wakaona the area is well wetted. Vaipwanya wakapena ngufuti.
Oh, okay. Yeah.
So them they are using it. They are using it more to give the crop enough water.
Enough water. Yeah. That's a good technique as
So
well. Yeah. Okay, so they just block at one
yeah,
end.
that's what they are using it for here. Where the slope is too much.
Mm-hmm.
Yes.
Okay. Yeah,
So they'll block once the water settles for about 10 minutes. Vaipwanya, they block with the pasogol.
Pasogol. Oh, okay.
Until the furrow is well wetted.
Well wetted.
Where the slope is too steep.
Okay.
Yes.
Okay.
So they use that technique also for the irrigation efficiency.
Oh, okay. No, that's a good one. Yeah. Okay. Yeah. So we can also look at now bench terraces. So these ones mostly they are done where you have a very steep slope. So what happens that if you have a steep slope like this one, so if you check this line, like this is the original slope. So what you do is that you cut the soil here and you place it here.
Yes.
So it will be like a bench here. Then again, you cut your soil here and then you put it here. Then such that you have, in the end, you have a structure which is a bench-like. But these ones mostly they're very expensive to do. So in most cases, these ones are last options where you've done all the other practices and they are failed. So now you just okay, we'll do benches. So yeah, in Malawi they do them a lot because Malawi is very hilly. So there's less land per se for agricultural production. So where you have steep slopes, they do make bench terraces. Yeah.
Okay.
Yeah. So it's one way of reducing. So these ones will reduce their speed at which water is flowing through this slope. Then the other thing that you can do is that instead of doing the bench terraces like this one, you can simply put stones across the slope. So like this picture here, we can have stones in this going in this direction, which will block the velocity of water going down and eventually will reduce the speed. But also, when
Mm.
you're using stone line terraces, in the end, you find that you can still end up
Yes.
with something like a bench terrace, because what will be happening is
Bench
that
terrace.
what will be happening is that the soil which is here, it will start eroding, going down here. But since here you've blocked it, it will get stuck here, such that
Yes.
here you have
Yes.
reduced the depth of soil here and increased it here. So it will be like flat.
Yes. Yes.
So you find that here it's flat,
Mm.
here it's flat, and here it's flat. So it will be like a bench terrace kind of structure. But the stones are meant to
Okay.
reduce the speed of water, and then reduce uh, 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 the erosion. Again, for this one, if you do
Okay.
this already, it means that this row here where there are stones, it means that you can't use it for
You've lost out.
for production. So you have to do your
Uh,
your economic analysis. Then there are
Mr. Miti,
yes.
Anyway, I'm trying to relate them to the erosion factors.
Okay.
These that we've discussed so far.
Mm-hmm. Okay.
Are they not in the P category on Zemanda?
Yeah. So basically, when we talk of physical structures, they are mostly in the
Yes.
in the P factor. So these the terraces, the
P
stones.
factor.
Yeah, you see
Yes.
the P
Yes.
factor. So in this case, you are
Okay.
in this case, it means that when you do these practices, it means that the P factor is reducing. So we know that the P factor, the maximum value is 1, means that when the P
Yes.
factor is 1, it means that you are not applying any of these practices. Then as you are applying these practices, that
Yes.
value start to reduce. Yeah, so you're very right. These
Yes.
ones, these ones are P factor interventions.
Okay.
Yeah.
Okay.
Yeah. So the next one is contour bands. So these ones, basically what you do is that if you have a slope, what you do is that you just dig and then make a contour here, like a hedge. So you dig and then make
Yes.
like a ridge per se, such that now you are blocking.
Yes.
Yeah, you're blocking this water from which is flowing from this end, or which is flowing from this side. So it's basically just making a blocking water in this direction. So we call them contour ridges. Contour ridges. Yes. I've in Kenya they use them a lot. They call them fwanya juu. If you just Google, maybe you just go to YouTube. You just go to Google and then do fwanya juu. You can see a lot of soil conservation practices in Kenya, which they use this this practice. Yes. So, but for this one, what they do is that when they dig in this trench where they've dug, they also they put plants as well as on the slope.
Yes.
So for this one, usually you don't lose out on any space because they utilize all the area. In the trenches, they plant something, as well as on the ridge. Here on the ridge, they plant something to stabilize the ridge. Then also on the slope here, they also plant something. So this one, in terms of losing out on area, it's very minimal.
Okay.
Yeah. Yeah. So
Okay.
yeah.
Good.
Yeah. So those are the physical measures. So they involve building of physical structures. So you can have those
Mm.
ridges, you can have the stones, you can have the check dams and the trenches and things like that.
Mm.
So those are the physical
Okay.
measures. Then now
Okay.
we'll move on to the agronomic measures. So yeah, so these ones, mostly the agronomic measures, they are going to influence the C factor.
The C factor.
Yes, so these ones,
Okay.
they will influence the C factor because they are agronomic. They are practices which involve like crop production. So they are
Okay.
yeah, they are agronomic in nature. So they usually influence the C factor. So
Factor. Okay.
yeah, so like by just as the term itself can speak for itself, agronomic measures. So it involves using of
Yes.
crop production systems or methods that are going to prevent soil erosion
Yes.
and compaction. So they work
Okay.
on three principles. So
Okay.
a measure that is applied can reduce soil degradation like in three ways. So firstly,
Okay.
they reduce the kinetic energy of the water as it passes through the surface.
Mm.
So in reducing that kinetic
Mm.
energy, they also reduce the rate at which it can be able to disintegrate to carry the soil away. Then secondly, they
Okay.
increase organic matter. So these practices are practices which tend to
Okay.
increase the organic matter. And if you have enough organic matter, it means that
Mm.
you have a good soil structure. And when you have a good soil structure, it means that your
Mm.
soil is well held together and it can resist erosion. Then the third principle is
Mm.
that they provide a cover on top of the soil, such that if rain starts to drop on them, on the
Okay.
soil, like they create like
Mm.
a sheet on top of the soil, so that the impact of the raindrops is not is not felt on the soil. So like we saw that
Mm.
soil erosion is accomplished in three stages. So the first stage is detachment, where the rain
Yes.
detaches small particles.
That one. Yeah.
Yeah, so this third
Mm.
principle is the one which counters that effect, where the raindrops, instead of
That's
disintegrating the soil particles will be
mm.
saved from that phenomenon.
Okay.
Yeah.
Or reduces detachment.
Yes,
Always.
reduce
Mm.
the detachment. Yeah. So the first practice that we can think of is obviously conservation agriculture. When we are looking at it from because this is agronomic, so we are looking at agricultural point of view. So we can look at a practice of conservation agriculture. So in this one, it's a practice which also works on three principles, where you have minimum disturbance. You don't plow your soils,
Mm.
so you keep the soil structure intact, but also you leave residues on top of the soil, so that the raindrops do not disintegrate the soil, and also they block the
Mm.
water as it passes through the surface of the soil. But also there's also a principle of
Mm.
crop rotation. This one will also aid
Yes.
in the organic matter accumulation. So you have, because of high organic matter, you have good soil structure. So conservation farming will ensure that the soil is conserved, it's saved from erosion, and because of the organic matter and minimum disturbance, you reduce on compaction. So conservation
Okay.
farming, yeah, would help in reducing erosion and also compaction. Yeah, so basically it works on three principles: minimum soil disturbance. So you just disturb the soil where you're going to plant. So if you have a field, you dig holes
Yes.
just where you're going to do your planting.
Okay.
Yeah. Then the second measure is contour tillage. So if you're on a slope, you make sure that your operations are all going across the slope. So if you're going to plant
Oh, yes.
if you're going to plant a crop, you don't plant it along the slope, but you plant them across the slope as it is in this photo. So your crops will go in this direction, your rows will go in this direction across the slope,
Okay.
and not in this direction. So when you do this, you're effectively blocking the water
Okay.
from moving
Awesome.
down slope at a high speed. And in this case, you reduce soil erosion. Then the third,
Just a comment on this one.
okay.
The contour tillage.
Mm-hmm.
Uma center pivots.
Mm-hmm.
There is the where we got options where you can make circular lines,
Okay.
or you can make linear,
Okay.
like ones that are just straight.
Straight, yeah.
So yeah, so you can either make them linear, like you in your center pivot, your lines are straight, more like linear.
Yeah, yeah, like they're
But
cutting across the field.
So this contour tillage, mostly like this one, I've seen it. For example, imagine if this were they are circular like this, you made them straight along the slope, there will be a lot of erosion.
Yeah, there will be a lot of erosion because
this picture, yes.
Yeah, because
So these are more like circular. So they're more like moving in a circle.
Yeah, these are more like moving
So
in a
if
circle.
you had putting
So if they
so
were
where we've got a very steep slope, this is the kind of lines that we make.
Yeah. Oh, okay. Okay, no, that's
Yes.
that's good. Yeah, so that you block the water from running off on the slope.
Yes.
Yeah.
Yes, because if you just made these lines straight, you can't grow anything there.
Yeah, it means that all the water will just
Yeah.
be going in one direction. As you irrigate, everything will be lost. Yeah.
Yes.
Okay. So the third practice is what we refer to soil surface cover. Now this one, like we said, the principle behind it is to reduce the impact of raindrops. So that cover, if you have a cover, as the rain is coming, it will be, the energy of the rain will be reduced by it hitting on these residues. So again, if you have these residues on in your field, it means that as water is running off, it will be blocked by these same residues. So this practice of soil cover will reduce erosion, and it will reduce erosion at two stages: the detachment part and the transportation part.
Transportation.
Yes, because as the water is blocked, it means that the soil particles cannot also move. So this type of this soil surface cover, there are two we can look at it in two ways. There's the plant residues, the dead plants, but also you can look at it as a live plants. So where you don't leave your field bare, but you grow a grass. You grow a grass to prevent the raindrop and the water water runoff. So what in some cases what they do is that after harvesting, during the time that they are not planting, you put a crop to cover the ground. Yeah, especially in areas where they experience rainfall throughout almost like throughout the year. So like even after they harvest their crops, they still experience rain. But when you harvest your crops, it means that your field becomes bare. So you need to plant a grass to cover your field and then prevent the erosion from occurring. So this is an example of a crop cover or a cover crop. Yeah, but also there are some times where you are growing for example, a tree crop. So in the spaces where there are no trees, you simply put your grass or any other crop that is going to cover the soil.
Yeah, I'm just thinking on the cover crop. Like some of these farmers, they grow sugarcane, but there's a time when sometimes they remove the sugarcane.
Yeah.
Then in between the sugarcane crops, like a green manure crop just to improve the soil.
Yeah. So
so they're also benefiting in terms of protecting the soil and also improving the soil nutrition.
The fertility of the soil. Yeah, that's also so that one.
Yes.
Depending on when they plant it, you can classify. It can go under crop rotation, or it can be an intercrop or a cover crop.
Okay.
So depending on depending on when they are planting it. So if they are planting it together with the other crop, the main crop, then it becomes an intercrop.
Oh yes.
Yeah, if they are planting it after the main crop, it can be like a rotation. So it depends on it depends on the scenario as it is obtaining.
Okay.
Yeah. Then there are what we call.
All right. No, thanks.
Yeah, they're what we call grass strips. So basically, this is just there's a particular grass. It can be any grass, but it should be a grass which is able to be very vegetative. So you just plant it in a row across your slope. So it will be like the stone lines. You just plant it across the slope, and it will block, for example, this grass strip here. So there's a strip here, grass, even there and there. So it will act to block water as it comes in this direction, so that it reduces the speed of water. Then crop rotation, we've talked about it. So mainly for crop rotation, it's increasing
Just a comment on
the grass strips.
Just a comment on the grass strip.
Yeah.
There's one grass we used to use here. They call it at vetiver.
Yeah, vetiver grass.
Vetiver grass. We used to put it like just per few days, panosira munda patch. So that in case of any runoff, the vetiver is able to stop the erosion.
Ah, okay.
But
Okay.
with time, we discovered that
Mm.
with time, we had a challenge where it started now encroaching into the field.
Oh, okay. Yeah. So that's
Yeah.
and these ones they are highly what can I say? They reproduce a lot.
Yes.
So it means that when I
Yes.
grow this one, it might
Mm.
increase such that your space now for growing your crops will reduce.
Is reducing.
Yeah. So
Mm.
yeah. So now you need to say okay, is this economically okay for me to grow this vetiver grass, or we use
Mm.
other measures.
Okay.
Yeah. So that's that practice. So like we said,
All right.
crop rotation mainly is for increasing the organic matter, and with increased organic matter, you
Yes.
have a good soil structure.
Yes.
Yeah. So that's mainly that's for rotation. Then there's what
I don't have that photo.
you don't have there.
I'm saying the notes don't have that photo, but it's good. I'll see it on the
Oh,
intro.
okay. Yeah, this one I just got it from from the internet. Yeah, just to show
Okay.
that the
That one is a good one.
yeah. But you can use this same PowerPoint just
Okay.
to see it.
Yes. Yes. Yeah.
Yeah.
Mm.
Then there's a practice which we call following. I don't know if I'm sure
Yes.
you also do it at Zambia Sugar, where you
Yes,
after
we do it. Mm.
after maybe years of production in a certain area, you just leave it
Mm.
to regenerate. So you just leave grass to
Eh,
grow there, so that you
uh,
so that the structure of the soil is able to go back to its original state. So you just leave it for grass to
yes.
grow. Maybe I don't know. Maybe it's for 2 seasons or 1 season or three seasons. Then again you start
The maximum we do here is 6 months.
or 6 months. Ah, okay, yeah.
That's that's the maximum.
Oh, okay. Yeah, so it would depend on it will depend on the farming practice that you're doing, but also like, because we don't want
Yes.
to leave land idle for a long time, because it means
Eh,
you're losing out on
for sure,
money.
production and cash.
Yeah. So
Yeah.
it will depend on those things. Then also
Yes.
the other practice is simply just adding organic matter to the soil. So we know that if we add organic
Okay.
matter,
Yes.
we improve the soil structure. And when we improve the soil structure, it means that there will be no compaction. And if there's no compaction, it means that you have good porosity. So instead of water running off the surface, it will simply go into the soil.
Yeah.
Yeah. Appropriate use of machinery. So if you're going to use machinery on your field, we know that machinery is heavy, and when it passes in the field, it will begin to compact uh,
Mm.
the soil. So what you need to do is that you need to make sure that the time that you're using machinery, you follow certain rules or guidelines which are going to ensure that these machinery do not compact your soil. So you can, to achieve this, you can use tires you can reduce the pressure on your tires as you are using
Yes.
the machinery on your farm, so that the
Mm.
base of the tires becomes flat, and it will reduce the pressure on the soil. But also you have to make sure that you reduce access of the machinery to the farm, meaning that you can combine certain operations, such that if you're going to do this operation, maybe for planting, at time of planting you also apply fertilizer, so that you just pass through the field once. But also you need to know how much weight can your soil hold. So you need to know what we call the bearing capacity, how much a soil can hold before it starts to compact. So the lower the bearing capacity, it means that you have to use a smaller track for your operations. And if the bearing capacity is quite high, then you can use a bigger track. Then you have to make sure that you
Mr. Miti,
yes.
I've liked that point you brought in.
Mhm.
How do you determine the bearing capacity now?
Okay, so this one is it's mostly an engineering property. So what they do, they get a soil like the way we get soil in core samples. Then they put it in a machine where now they start to compress it. They start to apply a certain pressure. So what they do that they apply a pressure and then release. They apply a pressure and then release. So you find that they are maybe at a lower pressure. What happens that when you compress the soil and you release it, the soil will still go back to its position. Then if you increase the pressure, you find that at a certain point, when you increase the pressure and compress the soil will not be able to go back to its normal position. So it means that pressure is what is the bearing capacity of the soil. It cannot take that pressure because it won't be able to go back to its normal position. Yeah, so that's how they determine the bearing capacity. So this one mostly you find it the people who use it are mostly those who have done agricultural engineering, because they are the ones who mostly deal with machinery on the farm. So they will do this this parameter, the bearing capacity. Yeah. But also, even those who do just civil engineering, they also they also do this parameter, so that, because for them what they want is that when they are building, they want to compact the soil so that the building is strong. So what they do is that they measure the bearing capacity of the soil, so that they know that for us to compact it, we need to apply a certain pressure. So so for them, they want to apply a pressure that is more than the bearing capacity, so that they're able to compact the soil and make the foundation very, very strong. Yeah. Then there's where when you are doing your farm operations with machinery, you have to make sure that the soil is at the optimum moisture content. So if your soil is if your soil is wet and then you pass a machinery in there, you find that it will start getting compacted because the soil is wet, and you have maybe the tracks of the wheels of the trucks, they'll start to compact the soil as they pass through the field. So you have to make sure that your soil is not very wet as you are doing your farm operations. Then the fifth one is that you have to keep your organic matter, of course, to a certain level, so that you improve the structure of the soil. And if your structure of the soil is improved, it means that it cannot easily be compacted. Yeah, so you just make sure that your organic matter levels are very good.
Okay.
So those are the agronomic measures that we can put in place to reduce soil erosion or soil compaction. Then
Okay.
they are what we
Then
call.
I've just remembered
Mhm,
one other way we are reducing compaction here.
mhm,
Though in Zambia Sugar we haven't really implemented it, but in other mills,
mhm,
like for us, because once we harvest the cane,
mhm.
we put the guys to cut it.
Okay.
Then we have to pick it using these heavy machines
Yeah.
to take it to the factory for crushing.
Yeah.
So you find that these haulage tractors that we use, sometimes they go up to 50 or 45 tons.
Ah, okay.
So what the guys in some other estates have done, they have established what they call traffic lines.
Mhm,
Like when a tractor is going into a field,
mhm.
they've established every year Ipitamasem.
Oh, okay. Yeah.
So instead of you accessing your field anyhow, wapita. So
Mhm.
they've put specific points where this
Yeah.
tractor can go in and come out,
Yeah.
so that it just avoids moving around anyhow in the field.
Yeah. I think that's
So they've
the
got
yeah.
controlled traffic lines.
Control traffic lines. Yeah, I think that's a good point. I
Yes.
think we should also, let me just add it on this PowerPoint, so we can say,
Yeah.
yeah, controlled traffic. Yeah, controlled traffic lines. So yeah, so you use the same,
Yeah.
pass through the same spots, such that you don't
Yes.
compact
Yes.
the other spaces. Okay, yeah, that's a good,
Yes.
yeah, that's a good one.
Yeah.
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 Okay. Okay. So now we can look at the biological measures. So when we talk of
Okay.
biological measures, these involve the use of living organisms. You use living organisms to protect the soil from degradation. So, but
Okay.
these ones, they may intersect with the agronomic measures. So certain agronomic measures
Mm-hmm.
are biological. For example, the grass strip or the cover crop, it's also a
Yes.
biological, it's also a biological measure because they are using living organisms.
Because it is okay.
Yes, but
Mhm.
not all biological measures are agronomic. So there can be
Okay.
other
Mhm.
biological measures which are not uh, agronomic. So
Agronomic.
yeah, so there's a thin line which you distinguish between the two, because there are other measures which are going to fall in this side and in this side. So all those which use
Mhm.
living organisms, we can say they are
Yes.
yeah, they can be said to be
Bio- bio-
biologic biological measures.
Biological.
Yeah. So but even other agronomic, you can classify them as biological. So when you say biological, it's simply, you use it mainly when you're looking at the environment per se. Then the agronomic, they are mostly
Oh.
concentrated to agriculture. So
Okay.
Yeah. So for biological, one of them that we can use, we can give an example of is a protective bushland. So this is a biological measure, which is
Bushland.
not,
Oh,
which is not an agronomic measure. So this one is where, like,
okay.
for example, if you go into an area, then you realize that if we disturb this forest, the soils will not be able
Yes.
to comprehend. For example, the way it is in Lusito there, if there was a proper
Yes.
environmental impact assessment, they would have said, no, let's not settle people here, because when they begin to cut trees, the soils will become
Yes.
vulnerable. So in that case, that area, you just leave it to be a bush. So you just protect it and say this
Mm,
area will just remain as a bush. So that's a protective bushland. So
oh,
you've used a biological measure where you've just left it to have trees and grass so that you prevent degradation. Then the other one,
okay.
which we can give an example, is a permanent grass cover in drainage ways. So for example, if you have drainages,
Oh, in natural. Oh, yes.
yeah, so you just
Yes.
plant grass in the drainages so that you reduce on
Mm,
the erosion of the drainage itself. Or you can plant grass in a gully so that it doesn't expand. So that's another example of a biological measure which is not agronomic. Then you can have uh, what we call hedges. So these ones mostly they are there to prevent erosion by wind. So for example, if you have a field, a crop
okay.
field, you just plant uh, hedges here, like these trees. So if the wind is coming from the other
Yes.
direction, it will be blocked and it will not carry the soil around this place. But when we come
Yeah, okay.
to water conservation, you realize that this will also help to conserve water. But when we come to water conservation, we're going to see how that is done. But in this case, we want to make sure that as the wind is
Oh,
coming, it's not carrying away the soils which are in this area. So those are the
okay.
biological measures. But of course, there are many other which we can see out there, depending on maybe in different
Yes.
countries, they will have different methods. But the principle is just that for biological, we are using living organisms to prevent soil erosion and soil compaction.
Oh,
Yeah,
okay.
yeah. Then we can talk of chemical measures. These are the last type of measures that we're going to discuss. Chemical measures. So yeah, so these ones involves uh, uh, the use of a chemical to prevent uh, uh, to prevent physical degradation. So we can use
Okay.
a chemical to prevent physical degradation, or we want to reduce the effect of a chemical on soil degradation. So this one, mostly we are going to talk of it in terms of salts in the soil. So for
Okay.
yeah, if we have a lot of salts in the soil, they will have
Mm,
three things that we can talk of. One of them is that
mm,
they will increase the osmotic effect, meaning that for plants to absorb
mm,
water from the soil, they will need to exert a high energy.
Yes.
Yeah, so if there's a lot of soil salts in the soil, even if you irrigate a lot of water, plants will not be able to access that water because the salts are the ones which are going to attract that that water. So that's the more reason you need to remove those salts from your soil. But also, if you have increased amount of salts, they can be toxic to your crops. Then finally, salts, there are certain salts like salts of sodium. Now, these salts of sodium are going to have an effect on the structure of the soil. So these ones are what we need to remove from the soil so that our soil, the structure remains good. So these are the three
Okay.
reasons why we need to remove salts from our soil. So to remove salts from the
Okay.
soil, we can use three approaches. So if your soil
Okay.
is saline, meaning that it contains a lot of salts, if the electrical conductivity is above 4, you need to
Yes.
the only thing that you need to do is that you need to apply more water than your irrigation requirement so that the salts are washed down the profile. So you can calculate what we call the
Okay.
irrigation leaching requirement, which is simply the ratio of
Yes.
the EC of the irrigation water to the EC of the soil. So this EC total is basically just the EC of the soil.
Okay.
So when you find this ratio, for example,
Okay.
yeah, for example, if this ratio is 0.5, it means that if
Yes.
you are going to irrigate, for example, 10 units of water, it means that you're supposed to add 5 units to that 10 units. So in short, you're going to have 15
Yes.
units of irrigation, so that that 5 will be used to leach out the salts. But now, if you have a sodic soil, so a sodic soil is one which is going to have sodium, and sodium is what we don't want in our soil because it will destroy our structure. So we can add gypsum. So this gypsum chemical is going to replace. It has high calcium, so the calcium is going to replace the sodium on the soil complex. And once you do that, now you leach your sodium to lower profiles. So after adding gypsum, and you irrigate your soils you irrigate and then also add the leaching requirement. Yeah. Then if your soils are saline and sodic, if you have both high salt concentration and high sodium concentration, what you do first, you irrigate your soil with with irrigation water that has a high amount of salts. So what you are basically doing, because you have high amount of salts in your irrigation water, when you apply it, what you want is that you want those salts to go and first remove the sodium from the soil complex. Then when you remove your sodium, you now apply water which has less salts, which is pure per se, but not necessarily pure, but which is as a lower amount of salts, such that now that water is going to first leach out the sodium and then leach out the other salts. Because if you just go straight and then put low salt water, what will happen is that it will leach out the other salts first. Then as it leaches out the other salts first,
Mhm.
the sodium will go and replace those salts which have been leached out on the soil complex. And now, if that sodium is on the soil complex, now it will start to cause structural degradation. So this is one way in which you can use chemicals to improve or conserve your soils. So up to here,
Okay.
we've looked at the different categories. That is the physical, the agronomic, the biological, and the chemical. Then in each category, we have seen the different uh, techniques that we can use to conserve our soil and prevent soil erosion and soil compaction. So these are some of the measures which we can use to conserve our soil, of which we can relate it
Okay.
to the universal soil loss equation to see where do they fall. Is it on the C factor or is it on the P factor? Then now you're able to explain, okay, if you have this practice, how does it reduce soil erosion? For example, if you have a soil cover,
Okay.
if you have a soil cover,
Mm.
say, okay, how does it conserve soil? So, okay, first you know it. Okay, soil cover will prevent the raindrop impact.
Detachment.
Yeah, and also it will prevent
Yes.
the transportation because it has reduced the velocity of,
Transportation.
it has reduced the velocity with which water is flowing on the slope. So we've seen these measures and
Okay.
we've seen the mechanisms by which they reduce erosion. So yeah,
Okay.
so like I said, you need to just understand, okay, if you have this measure, how does it affect, by what mechanism does it reduce erosion? And which, if we're talking of erosion, how does it affect the universal soil loss equation? So basically, that's what you just need
Yes.
to that's what you need to understand, because
Okay.
for these measures there are a lot more which if we are to put them in a module, it can be very
Mhm.
bulky. So the idea is that there
No,
are
you're right.
there are measures which maybe you may know, which I may not have come across.
Mm.
Yeah. So, but the idea is that if you
Yes.
know a measure, understand what
Mm.
what mechanism does it reduce erosion. So, for example,
Yes.
if uh, uh, if it's an exam question, then you put a measure which is not in the module, it's still okay, as long as you justify how it's able to prevent soil degradation. So
Okay.
that's the approach that we should take, because what will happen is that, for example, if you go to a conference per se on soil conservation,
Mm.
so you start to discuss, okay, we have this area in whichever part of the world. Then you start to discuss, okay, which
Yes.
method can we use? So as you suggest a method, you should be able to justify, to say, okay, in this area you have this condition, so the best method is this one because of
Mm.
this. They might not know that method in that particular part of the world, but if you're able to convince them
Mm.
that this is how it works, then it can be adopted. So It's the
Okay.
same. It's the same when you're in an exam, for example. Sometimes
Yes.
it's not about giving the correct answer, but I always look at an exam as something like a question that is posed to you as a group, that okay, we have this challenge, how do we go about it? So
Mm,
it's not that
mm,
you have to give the correct answer, but as you discuss with your colleagues, in the end, the input that all of you put in, you're going to come up with a solution. So
mm.
yeah, so the best is just to apply yourself, even if it's
Okay.
something which is something that you know a little about, but if you're able to give
Mm,
a concise, a logical thought, then it's something which can be built upon, and then you reach
yes.
you reach a certain level, and you're able to come up with a certain technology. So I think that's how we should approach
Okay.
yeah approach this course. So it's just about you understanding this measure. Okay, how does it work?
Mm,
Then if you do that, then it's well and good. You are
mm,
able to convince anyone. Yeah, yeah,
yes.
yeah. So I think we can end here for today, and then we will
Okay.
continue. Yeah, we'll continue tomorrow. So tomorrow we'll now switch to water conservation.
What the pushing.
Yeah,
Not pushing, at least we've covered quite a lot today.
yeah, yeah. So I think
Last unit two is done.
yeah, unit 2 is done. So for unit the one
Mm,
for water conservation, I think will take a little bit more time, because that's where we have some calculations which we need to go through. So yeah, so I think
no problem.
we'll take a bit of time. So maybe tomorrow. Tomorrow is Friday, and maybe even on the weekend we can see what.
Yes, right.
Yeah, we can see on the weekend what time we have. We can also go through, so that maybe next week we
Mm,
just do a few questions. We just go through a few questions. Maybe we'll go through some
mm,
past exam questions, just to see how to go about it.
yes.
Then also we get to look at the software as well.
Okay.
Yeah. So
Okay.
I think for today we can end here.
All right.
Yes.
Okay.
Yeah. Unless there are some
Mm,
there are some questions.
No, I've liked the this unit. At least
Yeah,
we equal practical and things that we can
thing that you see.
we can
Yeah.
relate to.
Yeah. Yeah. Yeah.
Yes, yes.
Yeah.
Mm,
Mhm. Yeah. Okay. Okay. Then I think
mm,
we'll stop
the-
we'll stop here. Then I'll send the recording.
okay.
Yes.
Any issue on our research?
Uh, not yet, because okay, I've not been at the office per se, because I've just been going direct to
Okay.
Unza Farm. So I haven't seen
Okay.
Mr. Piri. Maybe Milo,
Okay.
if he's going to come, then I can ask him if there's a possibility
Okay.
of you doing something on the in the project, under the project.
Okay.
Yes.
He mentioned something yesterday.
Oh, okay.